In this video, we want to understand why we're allowed to separate our variables and treat dy and dt as differentials in the separation of variables techniques for solving differential equations, some certain type of differential equations, specifically separable differential equations. So let's start with y prime is equal to g of t over h of y. This is one of our forms for a separable equation. In that, using that technique of separable equations, we rewrote this as dy dt is equal to g of t over h of y. And then we put all of our y's on one side and all of our t's on the other. So we rewrote this as dy h of y is equal to g of t dt. Or more accurately, we generally might write the left-hand side as h of y dy. So h of y dy is equal to g of t dt. And then recall we would integrate both sides, where we integrate with respect to y on the left and integrate with respect to t on the right. And that would be our solution to a separable differential equation. So why is this allowed? Let's start back at the beginning here with y prime is equal to g of t over h of y. Well, we can multiply, let's perform a legitimate step here, and that is to multiply h of y on both sides. So we get h of y prime is equal to g of t. This is completely allowed. So if we do that, we now have our differential equation in this form. Recall that y is a function of t. Right? That is our assumption here all the time if we're trying to solve a differential equation. That function with a derivative in it is a function of our independent variable throughout the rest of this equation. So y is a function of t. So really, if we integrate both sides here, we get the integral of h of y of t, y prime of t dt is equal to the integral of g of t dt. And here we are integrating with respect to t on both sides of the equation. We haven't done anything that is wrong or looks incorrect here. But we have y prime of t dt. What is that? That truly is dy. That is the derivative with respect to y. If we're thinking of dy as a differential again. So really, this left-hand side can be rewritten as the integral of h of y dy, where again, dy is that y prime of t dt. And so, in fact, we do get the integral of h of y dy is equal to the integral of g of t dt. Once this left-hand side is written in this form, this implies that we integrate with respect to y. So what we did here was between this step here to here is we made a change of variables. Okay, so that's all we did. We're used to doing that, so in use substitutions and so on. So that's all we did here was made a change of variables, and now we can integrate with respect to y. And it turns out this will always work. So we can kind of skip all of this step here, all of these steps here, and just think of the problem as we had previously in our examples, And think of dy over dt. Instead of thinking of that as the derivative of y with respect to t, we think of it as the differential dy divided by the differential dt. And we can separate those variables as we have done in our examples. All right. So that ends our video on why the separation of variables is allowed.